Hello everyone, welcome to AI Anytime channel. In this video, we are going to perform a fine-tuning experimentation. So this is going to be a DPO training on an open source large language model called Gemma 7b. So Gemma is an open source LLM by Google, released a month or a couple of months back when Google, entered back into the open source arena. And we are going to first perform, of course, SFT because you cannot, you can, but it doesn't make sense, right, to directly perform a DPO. So what we're going to do is we're going to take this Gemma 7b model, first use SFT, from transformers to fine tune it, and then again further fine tune using DPO for downstream tasks. We're going to use a couple of data sets. First, we're going to use Hugging Face H4 fast chat or some relevant data sets for SFT, and then we're going to use our DPO data sets by Arzilla, having all those context rewards and things like that. And in this entire exercise, we'll keep talking about why are we going with DPO and how should we do DPO. There are other alternatives, PPO, IPO, RLHF, and things like that. If you further want to, fine tune an LLM or a base LLM, or even a pre-trained LLM, you can do that. Okay, so a lot of confusions. There's so much things that so many terminologies, and I also have a fine-tuning crash course around 120 minutes video. You can find it out in my LLM fine-tuning playlist. I can give the link in description. I will recommend you watch that video first, then you watch this video because you should understand each and every details. Like I have tried covering out things like rope scaling when you set max new tokens, not max new tokens, max sequences, and for example, what is gradient accumulation, what is k-bit training, and all of these terminologies that you see when you fine tune LLM, you should have understanding. Otherwise, it doesn't make any sense. You can watch hundreds of videos like this, you will never get it. So you should first watch all of these, that how do we select LoRa modules? Like what do you mean by Q projection or a V projection or upward projection or whatever? You should have understanding of this. What is quantization, QQ? What is NF4? Different types of data structure, that bits and bytes you just said. So all of these things. You should watch that video and then come and watch this video. So we'll start with SFT. We'll take Gemma 7b. We're going to do SFT and then we're going to perform DPO training, one of the most used right now in the industry when it comes to fine tuning. And we're going to perform this in Colab and later part in RunPod. I'll tell you why in RunPod as well. Now, without any further delay, let's jump into Google Colab and see how we can perform this experimentation. So let's start our experimentation, guys. To experiment with this, okay, we're going to do this, of course, in Google Colab. Feel free to do this in RunPod, Lambda Labs, SageMaker, Azure Machine Learning Platform, Vertex AI notebooks, wherever you have compute, you can do that. You can do that locally as well if you have a workstation or a A100 or a V100 or even the newer Ampere architectures or the newer architectures that you have like RTX series and H100, you can do that. You need a good amount of GPU. You can see I'm on A100. It will not work on T4 and V100, excuse me. You need A100 and higher to do that. Okay, so this simple of compute, and we're gonna use Unsloth as we have discussed earlier. I have a very detailed video of Unsloth previously. I have YouTube shorts, I have videos on Unsloth. Unsloth, Llama Factory, Exaltog are different types of low code, no code tool that helps you in your fine tuning journey. To perform this, we're gonna install few things. I have whatever installation or thingy that I have, I've created some just to save some time. So I'm just gonna copy this here and gonna paste, and let's do that. So you can see I'm installing Unsloth from their GitHub, so from source, and I'm also looking at different versions of CUDA and things like that, finding out if the version is greater than equals 8, then you're gonna have support of flash attention, Xformers, and things like that. Keep one thing in mind, that if you work with transformers, Colab does not use the upgraded version. Okay, so you have to upgrade that. Okay, but anyway, it's installing, and I'm gonna write the next few things here quickly. We're going to import a few things. So the first thing that I'm going to import is, and let me just show you Unsloth because some of you probably have never used that. So 2 to 5x faster, 70% less memory, Q LoRa and LoRa fine tuning. Fantastic pitch, a one-liner pitch to sell their product. Of course, open source. When I say sell their product, I mean open source. Fantastic pitch. You don't have to write a lot of things, right? Just make sure that you are writing the necessary and relevant things. 5x faster, 70% less memory. That's what required for quantized fine tuning. Uh, Great documentation, a lot of notebooks to work with. Go ahead and try it out. But I'm just sharing you here. I'm gonna get a few things. So from Unsloth, import, and they have something called fast language model. So they would have created a lot of modules to work with, and I'm going to use fast language model. That's the first thing. From TRL, transformer, it's a transformer library. I'm going to have SFT trainer, supervised fine tuning. By the way, DPO you cannot directly do it. You need a base model that we're going to get it from SFT, supervised fine tuning, which has better alignments because it's supervised. Okay, it's like a censored model that you get. And you have to understand that it's when you train a model in some supervision, it's really censored. Okay, and that's why we need even some better fine tuning techniques for downstream tasks and whatnot, right? But this is beyond in this video. But let's get from transformers. We're gonna get from transformers. Auto tokenizer is required. Let's get auto tokenizer, and then I also need training arguments. Training arguments. Training arguments are done. Then I need data sets because we're going to use the data from Hugging Face. So let's get it from data sets, import load underscore data set. And let's get this first. Okay, we are done with that. Max sequence length, I have a luxury now in this video because I am on A100 using Unsloth, which also say that okay, we give you memory the reduced memory and everything. The compute, you don't have to worry about that. So I can have at least, no, I will not have 512. If you have compute limitations, you should keep a sequence length always lesser or small. But here I have the luxury, so I'm going to do a bit high, on the sequence length. I'm going to 2048. And my model is also not that compute heavy or the volume heavy. I'm going to have D type none and load in 4-bit. Yes, I'm going to get in 4-bit. I'm just going to replace that 8 with 4. Let's get that in. Now let's load the model with Unsloth and the tokenizer by, probably we'll get that the tokenizer from Phil Smite. Okay, I don't know how do we pronunciate him, but get it from Phil. He's at Hugging Face, Amazon, and fantastic guy, right? Helping a lot in the open source community. Loading the model. How do we do that? Model tokenizer. And when I use fast language model, let's see what it's giving us. Okay, so it says fast language model dot from pre-train, and then the model. So let me just bit more human readable. So model name equals to Eleuther. I'm not gonna use that. Okay, so I'm gonna go Unsloth Gemma 7B some model. Okay, and you can see this is the model I need. I'm gonna use this model. You can see 15,000 downloads. It says fine tune Mistral Gemma Llama with 70% less memory, blah blah blah. Same thing. Let's get it. So just replace this part. And we have our model name specified. Max sequence length equals max sequence length. D type equals D type. Load in 4-bit, load in 4-bit. We're gonna get the tokenizer. Pretty much the transformer thingy. So auto tokenizer from pre-trained. I'm not going to use this by the way. I'm going to use by Phil Smite, okay, or however we pronunciate his name. Okay, Phil is a great guy. Okay, he has a Gemma tokenizer, I believe. Okay, so I'm going to use this Gemma tokenizer chatml. Yes, this is right. I'm just taking my notes. Yes, this is what I have. Okay, so let me just get this guy here. And I'm going to use a param called use fast. I'm going to say, yeah, true. That's a Boolean value. So let's get that use fast equals true. Let's load it in and see what happens. It gonna takes a bit of time, guys. We are downloading and everything. So let's wait for that. By the way, this tokenizer that you see has been used by J4. Okay, so J for Gemma. Gemma is a model by Google, and I have a couple of videos on Gemma. Google came back with their open source initiatives. That was fantastic. Okay, so we have our model and config in, and a tokenizer in. Now we're gonna go into the next step where we're going to initialize and mount the LoRa adapter. That's the backbone of this video. We're gonna use LoRa. So let's initialize. This is how you do it. So model equals, and I'm gonna go fast language, and it has a get pift. It has a function called get pift model, passing the same model that we have, and rank. A bit pretty standard rank, not going too high here, otherwise memory will be a problem. Target modules. This is important, guys. Target modules I have taken from the documentation, whatever they suggest. They suggest queue projection, and if you don't know this, I will recommend go and watch my crash course of fine tuning LLM. That is really helpful. It's around an 100 minutes video of crash course, where on the how to fine tune LLMs, what all of these terminologies mean, vpros, qpros, kpros, everything in detail. You can watch that video. I'll give this link in description. Opros, I have get projection. After get projection, I have upward, and then I have down proj. Then when I have LoRa alpha 16 dropout, let's do completely zero here. LoRa dropout, uh, bias, of course, we're gonna have none here. You have to keep use gradient checkpointing as true. And if you don't know what do we mean by gradient checkpoint, you should watch that video. I have shown how GPUs are distributed and how that can be used, in my fine tuning video. And let's keep some random state. Okay, let's run this. It says patch 28 layer, blah 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 28. This is fine. Okay, so the model thing is done. Now let's load the instruction data set, because that we're gonna use for SFT. So which data? Let me look at my note. Data. So data has 10K version, not SFT. Let's see if we get anything here. Yeah, this is the data. So for that, I'm gonna do is data set equals. I'm gonna do load data set. Of course, I'm not going to have this, which is the tokenizer. Come here, just copy. You can see this is data prompt ID messages. A very good a text kind of a instruction specific data. Let's have a split. Train underscore SFT and then test underscore SFT. I think this will do. It will download. It's a bit big data, so it's going to download that. After that, we're going to set up the hyperparameters with the SFT's configuration. So I have n number of videos, on fine tuning LLMs, SFT config, and things like that. So we're gonna do it a bit fast. Okay, so let's try it out. Okay, we're gonna follow a lot of configuration from Jeffer, how Jeffer has been, or what's available in that Unsloth documentation. We're gonna follow that, but and it's going to take a bit of time, guys. Fine tuning. So of course I have to pause the video once that happens. But let's first see how we deal with this. Now let me start writing it. So data is fine, so let's do a bit quicker here. So now hyperparameters, so that's called training args. So training argues, or let's call it arg. Okay, training arguments, and inside this is going to be a lot of things. Do eval, yes, I'm going to do eval true. Evaluation strategy, yes, that will be epoch. Epoch, yes, epoch. or epoch, sorry, not epoch, that should be steps. I need every steps or whatever steps that I've defined on the evaluation. Evaluation strategy, let's call it eval step 100 is good. Or let's call it 50. Ah, excuse me. Output directory. Yeah. I know it's missing. Okay. Let's keep it 100 a bit high. Okay. We'll turn it for a number of, we'll see how many steps. Okay. So eval steps, save strategy is epoch, guys. Okay. Where we're going to check, looking at the checkpoint. And then we can define an epoch and save that. Okay. So epoch. And then save strategy, then per device, we need a training batch size. So per device train batch size 4, and then per device eval batch size is 4, and then gradient accumulation steps, let's also keep this 4. So this is making sense. Gradient accumulation steps, and then have a warm up ratio. To here I'm gonna have a warm up ratio equals warm up ratio. Let's keep it a list. 0.1 is warm up ratio, number of training epoch, and I'm gonna train only for one epoch, guys, but you should do it for at least 2 3 epochs to get better accuracy. So I'm gonna do this for one epoch. Okay, so number train epochs equal 1, and then I'm gonna have a learning rate E5. What should have? Let's keep it E5. Okay, so 2. How do we do that? So this is how we define uh, 2 E5 FP16. I'll do it a bit different way. So floating point half precision. Okay, so I'm gonna say not torch in, not in CUDA. Yes, CUDA dot is BF. They have something of function or something that says if supported or something. Okay, so is BF. Yes, this is how I'm gonna do that. Okay, so FA16. Then I have a BF16. Okay, so FP16, and then again I'm gonna do torch dot CUDA is BF16 supported. Okay, that was not, and then if that is supported, then follow BF16. And logging steps, let's keep it 100. Every 100 we're gonna log that. Save, let me just remove it now. Save total limit. Logging step is done. Optimizer, where is Adam, guys, when we need that? Okay, so Adam 8-bit and Optim, then learning rate scheduler. Learning rate scheduler type, it should be cosine. That's what Jeffers suggests. Cosine, and then seed equal for reproducibility. Let's keep that whatever we have kept on top, probably. And let's have an output directory. Okay, so Whew, I'm gonna have it here. Okay, output directory. Let's run this and see. Or should I create an output directory in Drive? Let's try it out. I mean, just this is just for you guys to probably learn it. Okay, SFT trainer. And in SFT trainer, I'm gonna have my model equals model, and then tokenizer. Let me just do it a bit order wise. So model and then tokenizer, and then it goes train datasets equals, I'm gonna just do datasets. Even if you do this first, it will make sense. It's a list we are going to the first, and if you just do eval as one, and then you're gonna have let's have max sequence length equals max sequence length, and after that I'm going to pass a dataset quarks as well, because that is important for some tokens. And if you want to add some special tokens, you can do that. But I'm going to say add special tokens, and that should be, I'm going to do a false here. Okay, template with a special token. So I'm going to do this false, and no need to add additional separator token also. So I mean, I'm just going to use one more key value pair here. That should be add, no, not add, append concat token, and then that goes false. And you can probably do this because it's good for a JSON schema. Now, uh, arguments, training arguments, where we are passing out training args, and I think we are done with this, guys. Then, okay. Uh, let's run it and see what happens. It's mapping. It will map at least to see. After that, we just have to start training. So we'll just do trainer.train to start the SFT. Once we have the SFT, we will gonna use that for DPO. We'll see that. Okay. And we'll probably push it to Hugging Face, but I have a lot of videos, if you because you guys ask it, right? How to push it, how to merge the LoRa adapters, how to inference it. I will recommend you guys to watch my previous videos. It's very difficult to create everything in a single video. You can at least watch two, three different videos to come up with the ideas that how you can mix it up and perform the task or execute the fine tuning end to end. Now I think we are done with the mapping, and after that, let's do trainer. We'll try it out. So what I'm gonna do is trainer underscore probably stats, and then I'm gonna do trainer dot train. Let's do that. And this is going to take a bit of time, guys. What I'm gonna do now, you can see that we are getting a folder created in the left hand side. I'm going to pause the video here and I will come back once it is done because this will take an hour and even more than an hour, I will believe. Okay, so I'm going to pause the video here and come back once this is done. All right, guys, you can see that our fine tuning for like SFT has been completed. Uh, took almost 2 hours. You can see it took around 1 hours and 46 minutes and 16 odd seconds for one epoch at for 500 steps. If you want to achieve it, train it for 3000 steps for three epochs. Then you'll get a better accuracy and kind of good performance. Here are the checkpoints. You can find out all the checkpoints over here that you can see here on the checkpoints. These are the checkpoints that we have that called checkpoint 593. And inside that we have our config, safe tensors, optimizer, scheduler, and things like that. And then we have our runs here that talks about that particular run, coming. Now let's get our DPO thingy. So what I'm gonna do is from Unsloth import fast language model. And if you look at the training loss and validation loss, guys, it started generalizing quite well, decent. Not, I mean, we 500 steps, you can't say anything, but if you look at the validation loss, it's generalizing well. The weights are generalizing really well. Starting from 1.0602199996. Better, but we need to fine tune it for more epochs and steps. Now from let's get our DPO thingy. So I'm gonna do is DPO trainer. Okay, DPO trainer. Let me just. Uh, I'm gonna probably copy this path, but this is fine. Okay, we need that from TRL import DPO trainer. Okay, from PIFT import. I'm gonna have PIFT model here, and let's get the PIFT model thingy, and then I'm gonna have transformer training argument and load data set, and I'm gonna have import torch. So let's get that. Now here I'm going to have max sequence length again. So max sequence length, and for this one I'm going to have it a bit small. I'm going to have d type none again, d type none, and then I'm going to have load info bit true again. Okay, so let me just run this, and I'll add few more cells. And here the next is I'm going to have same model tokenizer. Probably we can use the same tokenizer, but again, I want you to run this cell independently anyway. So I'm just going to do fast language model from pre-trained model name. And here we're gonna not call this model. We're just gonna call our checkpoint thingy. So let's call that checkpoint, or let me just copy this entire copy path, and I'm just going to copy this here, content checkpoint, and I'm just going to copy that. Max sequence length is max sequence length. D type equals none. D type equals none. I mean D type equals D type. Excuse me. I said it. Load in 4-bit. Load in 4-bit, and then that is done. And we're gonna have same tokenizer that we have. So tokenizer equals same tokenizer. So let me just bring this here. Now once you have done that, we're gonna load a data set. For this, I'm gonna use Arzilla data set. So Arzilla also helps you create synthetic data. Okay, so let me get the data sets here. And in data set, I'm gonna do load underscore data set. And inside this, I'm gonna pass Arzilla. And let me show you the data here. So you have to search for DPO mix, and they have a 7K data, Arzilla on Hugging Face, and this is the data that I'm gonna use. So let me just copy from here and come here and uh, do that. If you read this data, if you read it says DPO datasets built by Argila with distill labels. So Argila helps you create a lot of instruction datasets and different types of datasets. You can use that to create your own datasets for training, pre-training, or fine-tuning language models. That you can do it, using Argila. Now, you can find out on their GitHub repository, but this is the data that I'm going to have. So chosen, rejected, and I'm not going to, deep into DPO. You would have probably already, aware about DPO and would have seen that is a way where you can use a base model for further fine tuning, for downstream tasks. Uh, Rather than using a PPO, IPO, or RLHF, you probably favor DPO because industry is using DPO. So you would also have some idea of using DPO. Your manager would have said to use DPO, or your professor would ask you to do DPO, and you are reading somewhere on LinkedIn that people are using DPO, that we are using direct performance optimization. Performs really well, not the only way of further fine tuning a base model. Okay, but we're gonna look at DPO here. Let me just do that. Okay. Now for that I'm gonna have a column names. So column names equals, and then I'm gonna have list and dataset train feature. Let's get the feature. Okay. Excuse me. Features datasets train list. This looks good. Okay. Column names. Probably if you write out the column names. Okay. Let's get the column names over here. And you can see datasets chosen, rejected, chosen rating, rejected rating. Now already have created a function. You need a function that will basically as a DPO template that we need to apply. I'll go to my gist, and I'm going to take this function. This is the function that I already have because it's a bit of bigger function. So I'm just going to copy it here. Come, but I'll explain that. Now if you look at this function, it says for all k in example.keys for k in chosen and rejected. The inputs are triples of prompt, chosen, and rejected. Now that's important for this template where chosen and rejected are the final turn of a dialog. So keep in mind that we are doing it for chat, guys, right? For instruction based chat, okay, a chat model fine tuning that we are performing. Now need to extract the n-1 turn to form the prompt and extract the final turn to define chosen rejected responses, and then mapping on the data sets, applying that function, and then getting the split. Okay, that's what we are doing. Now you can let's print the dataset after this. So I'm gonna print dataset. You'll get a dictionary for this. You can see we got a dictionary. Number of rows for training was 6,750. For testing was 750 odd. Okay, and chosen, rejected, and prompt. That's what we have. Now again, set the hyperparameters. Okay, I'm gonna copy the same training arguments from top. So let me just go on top and get the training arguments, and we're gonna verify that quickly. So let me just Control A, Control C for DPU as well, come down, and then I'm gonna paste it. And here we have again do eval true, evaluation strategy steps, eval steps again 100. Again we have save strategy epoch. And then I'm going to replace per device train batch size. I'm going to make this a completely small one. And then I'm going to increase this to 16. And eval batch size again keeping same as train batch size. So 1, warm up ratio 0.1, number of train epochs again I'm going to keep 1. Learning rate, I'll increase probably the, let's change the learning rate. Okay, so in my notes I have 5.5e minus 7. So let me just do that as learning rate. This is also on Unsloth documentation or FE16. Again, this is same because I am using A100, so I can use that. Okay, now Optim is fine. Or let's we use, they say to use spaced addum. Okay, so I'm gonna use that. Okay, so I'm just gonna add here paste underscore addum w underscore 8 bit and then scheduler, and then again this is fine, this is fine. Let's probably keep this in a Gemma 7b DPO model. Or let me just this is fine. Okay, DPO model output directory, this makes sense. Now let's run this. Now I'm gonna have again use patch DPO trainer from Unsloth. So they have a module from Unsloth import patch DPO trainer. Yes, this is right. And then I'm going to initiate that. So let's initiate patch DPO trainer, initiating that. And then I'm gonna use trainer equal and DPO trainer. And here I'm going to pass. So the first thing that I'm gonna do is uh, first thing I'm gonna do is passing the model, then reference model. So my reference model is nothing here, so it's a none. And args are nothing but the training args. And then I have beta for DPO unit that I'm going to keep 0.05. That's what they specify for Jaffer model. And I'm going to have train datasets, uh, train dataset, and this goes datasets train. And then I'm going to have test dataset that going to have dataset test. And what else? We need tokenizer. Let's call this eval datasets. Okay, eval datasets, and then I'm going to have tokenizer. Tokenizer equals tokenizer. Tokenizer equals tokenizer. Now let's run this and see. Okay, I forgot to give that. Okay, comma. This is fine. Now it's gonna map this. So we're gonna use the after mapping. We're gonna just run this DPO trainer again. Again, it will take a few hours. So again, it will take almost 2 hours. So I have to wait for that again. But yeah, you would have the idea. You can also push it to Hugging Face, guys. You can use the HFFEI to push that. I'm not showing it. Uh, I'll leave up to you guys to figure it out. Just use HF API and just push it there on Hugging Face repo. But here we're just gonna see on the DPO, we're gonna look at how the validation loss, and it comes up with different metrics: rewards chosen, rewards rejected, rewards accuracies, blah blah blah. Okay, and we'll see how does that perform. But if you want to do a fine tuning using DPO of any LLMs, not only Gemma, this can be Mistral, this can be Mixtral, this can be Llama, this can be Alpaca, this can be anything. You can do you can follow the same notebook and you can do it. Now that is done. Now let's start training. You can see a folder has been created here in the left hand side. A runs has been, the task has been executed by Unsloth. And you can see step training loss, validation loss, rewards chosen, reward rejected, reward accuracies, and things like that. So what I'm going to do now here, I'm going to take a pause again and come back after an hour or something. It's just a lengthy video. You can understand how much effort it's going, right? I have to do it first for that 1 hour 50 minutes. This almost 2 hours. This will take, if I'm not wrong. So 3 to 4 hours of time that goes into fine tuning a simple of this is not usable, guys. If you want to use this, don't use it. This is just to tell you what's the step, how you can do that. Now you have to do it for more compute. If more compute is required, you have to do it for higher number of epochs and more steps with other evals like using optimum or things like that. Now, if you look at here, guys, right, while training was started, but due to CUDA error, and this is the problem with Colab Pro, and I never recommend that you should use Colab Pro. You should not use it. If you are ready to pay money, go for RunPod or Lambda Labs, which are like 1,000 times better than Google Colab Pro, because sometimes it disconnects and then the A100 GPU is not available. They say that A100 is not available. I am directing you to V100 or the other GPUs, and that's why it started giving. But what I did in that case, I'll show that. I pushed a checkpoint. You can see the checkpoint, and of course, I will delete the API key that you see it over here. I took the checkpoint where we saved the SFT trainer and I put it on the Hugging Face repository. Now it's available on my Hugging Face. As you can see, this is where the model can be found, which is SQMA 307 and JMA 7B SFT. I pushed all the model, uploaded it on Hugging Face. So this is the SFT one. And now what I am doing, I have started a new instance on my run pod, and you can see my DPU training has been started. DPO training, excuse me. I'll show that how I'm doing it. Everything is same. I have the same installation, and then I am just getting the max sequence length, D type, loading 4-bit true, and then I am loading my model directly from Hugging Face, not from the checkpoint locally, but from the Hugging Face using fast language model. Max sequence length equal to max sequence length, D type equals D type, and load in 4-bit equals load in 4-bit, and then using the same fill smite tokenizer. And if you come down, then I have the same Arzilla datasets DPO mix, and I'm using the column name, just getting it, and then you're applying the DPO template, and then the same training arguments that you could see in the Colab one, and the same patch DPO trainer, and then this is how I'm just fine tuning it. Now the fine tuning has been started, but probably it will take a lot of time. But if you look at this is how it, and once this is done, I will again push this on my same Hugging Face, but that will be Gemma 7B DPO over there. Now, if you look at here closely, it has a step training loss, validation loss, and then this is how the DPO metrics comes in: rewards chosen, rewards rejected, rewards accuracies, and rewards margin. Log PS rejected, log PS chosen, logits rejected, and logits chosen. Now, if you look at the validations loss, the model probably be now it started overfitting, I believe. We should not have been training it on whatever training samples that we have. It's for 6,750, but I think I should have trained it for a fine tune it for a bit lesser amount, the steps. The model is now started fine tuning it, but I will publish that once this is done on Hugging Face as well. The same code from here. This is how you can use. You can use Hugging Face API to do that. You have api.create repo and then api.upload folder. So the folder that you can upload using this repo ID, username, model name, and the folder path, and just have to change repo type equal to model because it also had data set over there. Now, once that is done, I'll be pushing it over there with the evaluations and everything, and you can find it out there. But I hope you got the understanding of how to first train an SFT and then use a DPO data sets and a DPO architecture to basically, further fine tune it for direct performance optimization. That's how you do it. And you can see the repository has been created over here, and there's nothing right inside. There will be a run shortly, but all of these will be stored here, and then I'll be pushing it on my Hugging Face. I hope you got the idea, guys, and this concludes our experimentation of fine-tuning GMA 7B with SFT and then DPU. So this was the target, to fine-tune fast fine-tuning, of course, because we are leveraging Unsloth and just using the Jaffer recipe, because we have used a lot of hyperparameters directly from Jaffer and DPO training for Google Gemma. I hope you got the understanding. And if you have any questions, of course, about this notebook and the steps, please let me know in the comment box. And this concludes our experimentation with Gemma fine tuning with DPO, guys. That's all for this video, guys. I hope you developed a bit of understanding, a bit of skills on how to take any base LLM. You can take any LLM, not purely it's on your choice. You should not only take Gemma, you should try with Mistral, Llama, Alpaca, and things like that, Falcon and whatever. But you have to be aware of few things. LoRa target modules needs to be different for different. You have to go through a bit of understanding of how they have been trained. The best thing will be to look at their config file on Hugging Face or wherever, and look at their research paper if they have something like that, and then you can select the right hyperparameter to do that. If you have any questions, thoughts, feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Uh, if this notebook will be available on my GitHub repository, so you can just go and take it from there, fork it, and use that for your fine-tuning purposes. Let me know your findings, of course, in the comment box. If you haven't subscribed the channel yet, please do subscribe the channel. And if you like the content I'm creating, please hit the like icon. Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.